students, I am Tulika Banerjee. Today, I bring you the next learning episode in BSc Forensic Science on an important unit of the paper titled Fingerprints, that is Biometry, Poroscopy and Edgeoscopy. In this lecture, you will be studying about biometry, poroscopy and edgeoscopy and also the study of fingerprint patterns at various levels. In addition to it, we will give you a detailed study of poroscopy and edgeoscopy. You will also be studying about the biometrics performance system. We will wind up this lecture with a conclusion. So dear students, let's start our today's lecture with a brief look at what we will be learning today. First is introduction, then study of fingerprint patterns in various levels, then we have detailed study of poroscopy and edgeoscopy, then we have biometrics performance system and lastly the conclusion. Forensic science largely concerns the analysis of crime, its existence, the perpetrator or perpetrators and the modus operandi. The science of biometrics has been developing approaches that can be used to automatically identify individuals by personal characteristics. Biometrics, poroscopy and edgeoscopy are usually concerned with the recognition of persons based on their physical or behavioral attributes. So far, biometric methods have been chiefly used to assure identity. The biometric studies are concerned with finding a set of features which provides the least deviation between the different samples of one individual and most separability between the samples of one person and the rest of population. These features will provide the best chance for individualization. In fingerprint recognition, the most popular and widely used features are the minutiae based features or characteristics. Such level of consensus, though, has not been reached for most of the biometrics traits, and the best set of features is subject to constant examination. One of the most important purposes of collection of physical evidence is to establish the identity of the suspect. The identification is possible through a variety of evidences. Fingerprints are considered to be one of the best means for personal identification. Any person or individual can make an attempt to change his or her voice or handwriting, but it is impossible to change fingerprints because they are unique. Even the fingerprints of two fingers of the same person never match and are permanent. The palmar area of the hands and the plantar area of the feet, comprising of distal phalanges, has ridged skin and are known as papillary or friction ridge skin, as given by Schrotter in the year 1814. These ridges, once formed in fetal life, grow in size and rest will remain unchanged throughout life and even after death or till the bodies get decomposed. If the epidermis is injured, it regrows very swiftly till the injury has not entered deep into the producing layer of the epidermis. The shape of the ridges on the healed surface will be identical with the pattern as it existed prior to the injury. In 1914, Locard published assumptions in relation to fingerprint identification and the standards which are used to reassure dependability founded upon this statistical analysis. His study presented the given tripartite rule that the certainty of identity becomes beyond debate if more than 12 concurring points are existing. If 8 to 12 concurring points are present, then the case is marginal and the inevitability of individuality will depend on the clarity of the fingerprints, the rarity of its form, the core and the delta in the available part of the print is present, the presence of pores, that is poroscopy, the papillary ridges and valleys, the direction of the lines and the angular value of the junctions, that is ridgeology or edgeoscopy. If lesser number of characteristics is found, then the fingerprints will not provide identification, but only an assumption to the number of points available and their clarity. These observations were generalized by Steenwender in 1958 regarding the value of 12-point threshold. But in several cases, the fingerprint impressions are incomplete, smudged and disconnected or defective due to various reasons. That is, the essential number of rich characteristics are not available. It is a great handicap for the experts to give opinion on identity in such cases. In such situations, there is a need to include the third level details, that is number, shape and relative position of sweat pores and shapes of the edges of the ridges. Locard in 1912 considered pores or the study of pores as poroscopy, which are found on the finger ridges, and how they can be used in the individualization process. He also understood the importance of the form of edges of the ridges, which are also permanent features like any other ridge characteristic, and is called as Edgeoscopy. Edgeoscopy is defined as the study of characters present on the edges of the finger ridges, and Poroscopy is defined as the study and comparison of sweat pores. Both of these are used as a tool for personal identification. The features of the edges present on one or both the sides of ridges with an insufficient second level details or Galton's details and the presence of pores in their correlative locations are adequate to ascertain the identity, as provided by Chatterjee in the year 1962. Very little work has been done on Edgeoscopy and Poroscopy in the field of personal identification, and hence it was thought necessary for a detailed study on partial, smudged or fragmentary fingerprints and setting up of standards with the purpose of identification by employing the first, second and third level details. The outcomes acquired from this research were predictable to be supportive in identification, chiefly in those fingerprints in which appropriate number of ridge characteristics or Galton detail are not available. Fingerprints are the prints formed by the papillary ridges at the distal position of fingers and thumbs. These ridges of the fingers are formed in third to fourth month of their fetal life and, except for growing in size, remain unchanged throughout life. Prints are generally decisive evidence. Experts' report should consist three possible findings. First, the subject made the prints. Second, the subject has not made the prints. And the third, the print had insufficient details to be evaluated. The patterns formed by the ridges never change throughout a person's life. Criminals have often tried to change or destroy their fingerprints, but they always grow back in exactly the same pattern, or if the damage is so severe, enough to be exchanged by patches of scar tissue which forms recognizable patterns. The study of any fingerprint starts from the type of pattern the fingerprint sample has. Therefore, based on the patterns formed by the friction ridges in the center of the fingerprints, the patterns can be classified into four categories. First is arch, second loop, third whorl, and the fourth type is composite. The frequency of loop pattern varies from 65 to 70%, whorl and composite from 25 to 30%, and arch pattern is 5% as given by Chattopadhyay in the year 1975 and Bandyopadhyay and Dasharma in 1995. The pattern arrangements are class characteristics which forms first level detail. Overall, ridge count and orientation of the print are other details used in the identification process. These characters in it do not provide enough uniqueness to the fingerprint to individualize. Even though the pattern classification excludes non-matching prints, most of the partial prints obtained from the scene of crime are so disjointed that the pattern areas do not show up at all. Hence, identification of prints should be based on more comprehensive examination of the minutiae characteristics which are independent of the pattern comprised in the second level detail. The features which are taken up in this section includes bifurcations, ridge endings, dots, enclosures, bridges, lakes, etc. If sufficient number of these characteristics are found at their correlative positions in evidence prints and on prints taken from the suspect, that is the specimen 1, and if no difference is seen, the prints are considered to be from the same finger. Every feature can be recognized in terms of type of pattern, its root and its position with respect to other distinguishable features in the print. The first and second level details are adequate for establishing identity of the fingerprint. However, There are situations wherein the print is too smudged or blurred for the purpose of identification, or the print is so incomplete that it allows only limited number of characters to be identified. These prints are called chance prints, wherein variations in conditions are so many that some other details are required. This is called as the third level detail. The third level details comprises of poroscopy and edgeoscopy. Edmond Locard, a French criminologist, developed the process of establishing identity by comparing sweat pores on palmar and the plantar surfaces, and this he termed as poroscopy. The pores look like the minute openings present on the mouth of ducts of sweat glands. Pores on sweat glands comprises of unique differences which are persistent throughout life. They form a valuable series of individual characters that can be used in criminal investigation and in cases where the record is too incomplete to show a definite pattern, or too fragmentary to make out even the rich details with certainty. Certain factors such as quantity and quality of the ink used, the degree of the pressure applied in taking an ink print, or how an article is touched, the smoothness of the friction skin, etc. affects the visibility of sweat pores. Sweat pores are situated on the ridges and they vary in shape of the pores, size of the pores, position of the pores, and number of pores per unit area. The opening of sweat glands, that is sweat pores, are arranged on the ridges of friction skin, and they can be of various shapes, that is triangular, circular, oval or rectangular, etc. They may be placed in the middle or at the periphery of the friction ridge. Like fingerprints, the shape of pores and their relative position remains constant throughout life, and they are variable in different fingerprints. The size of pores may vary with the advancement of age, but their nature and relative position remains constant. Number of pores per unit area can be calculated as the average number of pores that occur on the given length of the ridge or found within the given area. In a research work, the different features of the pores, namely their shape, size and position in the areas of the skin, have been studied in the ink prints. Chatterjee in 1962 envisioned edgeoscopy as an identification process where the characteristics of the edges of the ridges of friction skin would be compared and evaluated. These characteristics are the alignment and shape of the individual ridge unit. The edges of ridges are also unique and are persistent like ridges and pores. The characteristics of the edges of the ridges do not change during the life of an individual, though their size can vary with the advancement of age. Chatterjee in 1962 classified the characteristics of the edges of the friction skin into 7 classes, starting with straight edge, convex edge, peaked edge, table edge, pocket edge, concave and angular edge. The types of surface on which these chance prints appear and the kind of ink used affect the visibility of these ridges. To sum up, holistic approach to identification of the friction ridge surface is required. During the identification process, experts presently tend to explain and demonstrate the identification only on the basis of number and sometimes on the type and ridge characteristic. The holistic approach explains and mentions further aspects. Persistence and uniqueness are the foundation on which the science of fingerprints is based. If this is true for ridge flow and minutiae, it must follow that it is also true for the other aspects of ridge structure. The manner in which this information is used in the identification process has been explained here. First is the first level. Overall pattern arrangement. This does not have sufficient uniqueness to individualize. The pattern formation is probably the first aspect that an expert is using in the identification of fingerprints, but is very rarely mentioned in explaining the identification. For example, if an expert compares a loop pattern mark with a whorl pattern, and if the two items being compared are of the same pattern, then this is considered as the first step in the identification process. Second is the second level. That is the specific flow of the ridges, a specific path of accidental features such as the scars, subsidiary ridges and flexion creases, etc., and the location of ridge characteristics. Identifications are currently processed on the basis of the number and sequence of the ridge characteristics. Although ridge characteristics on subsidiary ridges are sometimes used, the fact that subsidiary ridges appear in two impressions is by itself an aspect that could be used in the identification process. Fingerprint experts would state that scars and flecks and creases are never used in the identification process. However, most of the experts agree that they are used in the searching and the initial stages of the identification process. All these are aspects of the identification process. Most of the experts use number of characteristics and the coincidence sequence to explain and demonstrate the identification. Next is the third level. This level comprises of the study of edges present at the friction ridges called as Edgeoscopy. Also constitutes thickness of ridge unit thickness, thinness and location of relative pore, and this study is called as Poroscopy. Third level detail is always used in agreement with the second level detail. That is the additional aspect that experts are expected to look for. As mentioned here, it is used along with the second level. It includes the items mentioned and adds strength to explain and demonstrate identifications and or the non-identifications with a limited number of characteristics. The expert must evaluate the clarity of the print before forming an opinion. A biometric system can be used as an assistant tool in the forensic scenarios for helping on queries against a large enrolled database. The query can be a one-to-many search to determine potential matches to a probe from the gallery, or a one-to-one check to verify the identity of an individual. Both tasks are called as identification and verification in the biometrics research community. In identification, the biometric system searches an enrolled database for a gallery sample matching the probe sample. An ordered list of top n matches may be returned as the possible identities of the probe. The performance of the system is the identification task is measured in terms of rank n recognition rate, which is the rate at which the true association has been included in the top n matches of the probe. Recognition rate is the simplified term for rank 1 recognition rate, where the system returns a single match, the best match, as the most probable association for the probe sample. On the other hand, verification is the task where the biometric system attempts to confirm an individual's claimed identity by comparing the probe sample to the individual's previously enrolled sample. Verification is based on a decision threshold. This threshold is set by comparing all sample pairs in the gallery. Second is false rejection rate, or FRR. It is the percentage of times when an individual is not matched to his or her own existing template. In other words, FRR is the percentage of the genuine scores which are lower than the decision threshold. The third type is the equal error rate, or the EER. Is the rate at which both acceptance and rejection errors are equal, that is, FAR is equal to FRR. Usually higher will be the accuracy of the biometric system if the EER value is low. Automated biometric techniques can be used to analyze and interpret biometric traces in the forensic scenarios, such as an investigation of a criminal offense and the demonstration of the existence of an offense, as stated by Muley in 2012. These tasks are usually interrelated with each other. Biometric techniques are used to help in three main ways. First, in decision. In identity verification and identification, a decision needs to be made. Such applications include criminal ID management, suspect or victim identification, etc. Second is selection. In forensic intelligence and investigation, biometric techniques are used to link cases from biometric traces and generate shortlists of candidates. Third, description. In forensic evaluation, biometrics is used to describe the evidential value of the biometric evidence. Fingerprints are a valuable piece of evidence in solving of criminal investigations, but only pattern studies of the fingerprint sample does not serve the whole purpose, because in most of the situations partial prints are obtained where it is not possible to go in for complete systemic classification, and other details should be studied and compared in for such as poroscopy and edgeoscopy. Biometrics is also a new field where it is being employed in solving of criminal cases. With all these information, here we come to the end of today's lecture. Do keep in mind what we have discussed today. I'll be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website, that is www.cec.nic.in, for MCQ quizzes, LORs, etc. Thank you for your time today. I'll see you in the next lecture. Have a great day.